Let's go ahead and begin. Welcome again, everybody. My name is Terrence Mulligan. I'm the president and CEO of Napa Valley Community Foundation. Thank you for being with us this evening. As some of you already know, Napa Valley Community Foundation works side by side with local donors and nonprofits to tackle the most important challenges our valley faces. We believe that a prosperous community rises from a strong foundation. So every day we gather generous hearts and bright minds to solve the problems that lie just beneath the surface of this beautiful place we call home. Because when we harness the power of our collective generosity, we become a force for good, making life better for everyone. Last year in 2020, with your support and donations from more than 2,000 other generous people, we distributed $13.2 million in grants to make Napa Valley stronger. We invested in youth through scholarship and academic achievement programs. We fought poverty by launching an innovative affordable housing program that aims to accelerate the adoption of accessory dwelling units. We championed community by helping several hundred of our immigrant neighbors become United States citizens. But more than anything, last year in 2020, we sprinted against COVID-19. Indeed, of the 13 million and change that we distributed last year, a little more than 5 was aimed at blunting the health and economic effects of the novel coronavirus. The biggest piece of that, 4 million and more, was distributed directly to undocumented heads of household who fell into economic hardship because they lost jobs or wages and were unable to step forward for unemployment benefits or for stimulus checks, or for PPP loans. Importantly, within that, and that was about 1,700 unduplicated households, by the way, there were about 450 households that were, I don't know if it's mandated or requested by County Public Health to isolate and quarantine. And it was our view, and the County Public Health Department's view, that they might need an economic safety net to do so. So I'm really proud that with your help, we provided a couple months of economic support, basically wage replacement to these families so that they could get well and recover, and that the rest of us could remain safe because they were staying in isolation and quarantine. Here's what we didn't do last year as it relates to COVID. We didn't attack the virus itself. We didn't study the virus itself. Instead, we responded to the suffering, the illness, the economic damage that it caused. And that's why I'm so excited to have Dr. Melanie Ott with us this evening from the Gladstone Institutes to talk more about her work at the root of this problem of ours. Before I introduce Melanie, a few procedural bits. You're all veterans by now of this format. So you know that we're recording this. You know that we can't show all your faces as much as we'd love to, but we really want to get you involved after Melanie gives her presentation. So there's a Q&A icon at the bottom of your page. That's how you can pose questions. We'll do our best to get to all of your questions. Along the way, we hope to put up a couple polls because that's what the cool kids are doing these days on Zoom calls. So I hope you'll participate in those as well. So you saw Dr. Ott's bio in the invitation that I sent you, and I'm not going to walk you line by line. She is both a medical doctor and a PhD. She is the director of the Gladstone Institute of Virology. She's a professor of medicine at UC San Francisco, and a scientist held in highest esteem by her peers globally. So without further ado, I extend a very warm welcome to you, Melanie. Thank you for joining us.
Well, thank you so much, Terrence, and thank you all for coming and spending this hour with us. I really do admire what you do in the foundation, and I'm really excited to be here and share a little bit what we do, which is a little bit more abstract, but nevertheless as passionate as what I hear what you do with your work. So I wanted to take at the beginning just a little bit of a step back and bring us back a year back, you know, and want to tell you where we were sort of last January. I mean, you all might remember you came out of the not this January, last January in 2020 when we came all out of the holidays, and we had heard about the Wuhan virus, but we weren't really sure what to make out of it. But it it was clear at that time that it was not contained in Wuhan. And I think all of us had a very uneasy feeling about it. And we as virologists were very closely watching it. So that was the scenario basically in January. That's when we started.
And at that time, the lab that you lead was focused on things like HIV and AIDS and some other things. So tell me about the pivot, like with what degree of suddenness did you move all of your resources against this virus? And you know, what sorts of things have you been doing since that time?
Yeah, thank you. So yes, we have been working on many viruses in the past, most notably on HIV. It's a long-term research focus in the lab since more than 20 years. But we also worked on hepatitis C, on Zika virus, on the flu, very recently actually. So that was something that we thought would help us pivot because we had a lot of reagents at hand that could be converted. So in January, as I said, we all watched this virus with unease. But at the same time, something else happened last January, and that was really, I would say, the start for many labs around the world to begin working on this virus. And this was that the Chinese researchers posted the sequence of the virus, and that was very long awaited. It's basically a bunch of letters that explains to us what exactly is the code, the genetic code that virus is carrying. And that allowed us to do a lot of things, even without having our hands on the virus at that time. And I think that was for many labs, the beginning of looking into how can we help, how can we be prepared, how can we contribute what we have to helping to understand this virus very fast, because it became clear that it would become a larger problem. Nobody imagined at that time that it would become the problem that it is today. But I would say many foresaw that this was, you know, a problem that we will have to deal with worldwide. Mm-hmm. So I think what we did is we had two things at hand at that time. We had been working on the flu, as I told you. And we had little mini lung organs in culture that we were growing, and that were very well representing the environment that you have in natural organs and lungs and the upper airway. We knew that they were very well infectable with flu, and we did a lot of studies in them. And so we felt that this is something that we wanted to use to study SARS-CoV-2. But for that, we needed the virus. That was a long way to go, because from the sequence and the letter code to the actual virus is quite a journey. But to do this, we needed to build a high security biosafety laboratory at Gladstone. We do have high security biosafety laboratories, but not airborne pathogens ones, so that those that protect us against respiratory viruses. We classically have bloodborne pathogen high security laboratories that allow us to work with HIV and hepatitis C and other dangerous viruses, but we did not have an airborne pathogen BSL-3 or biosafety level 3 laboratory. So we started in February basically to find ways how we could get into such a facility in order to obtain the virus and to work with it and to really study it.
Goodness. That's a bit more than putting a box fan in the window, isn't it? I mean, what sort of investment was required to, and is it on site? Was it built within your current footprint, or did you go elsewhere?
So I think we initially went elsewhere. There's two BSL-3s, airborne pathogen BSL-3s at UCSF, one across the street, one at Parnassus, but they're all used for non-viruses. They're all used for tuberculosis classically. And so there was reluctance initially to mix pathogens to go into these, laboratories. And I think I could understand this. Eventually, nobody was allowed to work on tuberculosis anymore because we had to, stop all non-essential work. And then all these facilities opened up for SARS-CoV-2 work. And that was a blessing, because we had put all our organizational and administrative, we had put everything in order. Everything was submitted and approved. So once the laboratories became available, we could go and start with the help of my colleague Anita Seal at Parnassus, who kindly hosted us. And hosting in this case means that they had to go with us in the middle of the night at 10 o'clock, because initially they had to to sort of supervise us to make sure that everything is safe and everything is in order. So they had to get up in the middle of the night and harvest cells for us and do experiments. So they were really, really critical to us to get started. In the meantime, we were told that, and we knew that the space is limited at UCSF. We only have 2 relatively small laboratories, so we began to build our own at Gladstone. We had a previous one that was on our 6th floor in our animal facility, mainly for animal work, that was in the footprint and had all the security measures that in place from the structural, from the building part. So we went back to that facility and basically reactivated it. So we didn't have to start from scratch. We just had to upgrade it, but we had to get a lot of inspections in place during a time of complete shutdown, which was in times quite dramatic, because we had the inspectors driving up in the middle of the night from Irvine in order to be here in the morning to help us inspect the facility. And it was unclear to us in the morning if they would show up or not, or whether they would be falling under the absolutely no travel order. So there was a lot of drama involved, but I must say it was an amazing effort that everybody put in place, because I think everybody knew from the UC, starting from UC to Gladstone to other contractors that helped us, that this was really a race with the time. And we opened this facilities months ago and have been working in there since then 24/7 basically. So that was a major step at the beginning, and that allowed us to use, for example, our little mini organs to infect them eventually with a virus. And now we have not only the initial virus, the Wuhan virus, we have now also all the variants and other and mice in place in this facility in order to be able to really work and study the virus. So this was an enormous blessing.
I know I want to get us into the variants next, but would you mind speaking? I was so amazed to learn about, there's a host of things your lab has done that's helped us all, that's put us in a better footing for next time. And the one that resonated with me was on the diagnostic side. And I wonder if you might speak about the work that you're doing presently. As I understand it, you've got a bit of a beta test going with a different sort of diagnostic tool. Could you talk some about that, Melanie?
Yes, absolutely. So we, as I said, everybody took stock last year and thought, what do I have that could be helpful? And our immediate thought was, we have been working in a wonderful collaboration with Jennifer Doudna and Dan Fletcher from Berkeley. Both are also part of Gladstone, on this diagnostic device that we were very excited about, that we initially built for HIV testing. Again, you see, we do things for one virus, but we can pivot them relatively easy to another virus if it's necessary. And so this was a great combination of, the pioneering work that Jennifer did in the CRISPR field, and the very equally pioneering work that Dan has done with using mobile phones as diagnostics. And this has been a long-standing real passion, I would say, from all three of us, where we really tried to bring this together and to use the CRISPR enzymes not only to gene edit and cure diseases, but to use it as a diagnostic, because it can find directly the genome of the virus in samples. And without any further amplification or PCR reaction that is usually taking place, can directly detect it, and we can make the sample glow if it's positive, and that glow can then be picked up with the camera of a mobile phone. This was very much still a theoretic model at the time in last January, but I think we have moved in the last 1 year and a few months in an incredible speed forward. So now we have a version 3 of a device that basically uses a mobile phone and has at the camera a little optic and a little laser. So when you have a nasal swab, and you can then directly basically extract the genome out of it. It gets into contact with the enzyme, it starts to glow, and it is basically all run and counted by the mobile phone. So our vision is really that one day we can all get up in the morning, brush our teeth, take our nasal swab, test it in our mobile phone, and then decide whether we are positive or negative. And if we're positive, we stay in quarantine, and if we're negative, we go out and we mingle. And I think you might think that this is not any more necessary because now we have wonderful vaccines, but unfortunately we know that vaccines not completely prevent asymptomatic infection. People can still become infected without even knowing it, which is wonderful because it really prevents disease and hospitalization and worse. But I think we still have to monitor the spread of the virus, because that can lead to mutations and potentially to variants. That is what keeps us all from sleeping these days.
Of course, this whole idea, which is just amazing, of high cadence I don't know what the word is, self-performed, low cost, such that it becomes rapidly scalable and available to everybody. One of our more recent guests was the Dean of Harvard College. They have the resources to do high cadence testing, but City College of Santa Barbara does not have those, and so there's inequities in all this, that such an innovation could really work to overcome, which is just fantastic. Mindful of the time and the fact that we want to talk about variants next, I wonder, Luz, could you put up our first poll as we enter our next branch of discussion with Melanie? There it is. Okay, so we'd love you to take this poll and share the results. It's an easy one. Let's see what it looks like. Here we go. Look at this interaction. My goodness, what a crowd.
Wow, I'm impressed.
How about that? Napa County doesn't mess around. We've done a good job here. Wow, so 85. And I hope that our guests can see, yeah, by the way, it is anonymous. I wanted to say it's an anonymous, but all of the polls are anonymous. Thank you, Julia, for reminding me. I'm hoping that our guests can see, I know I can see it. So 86% of you are fully vaccinated, 9% are partially so, and 6 are waiting their turn. I think that all adds up to 100, so thank you. So let's talk about variants. In the press, one reads about a sort of epic foot race between the vaccine rollout on the one hand and the troublesome popping up of new variants of the virus. Can you talk about that with us and tell us what you think?
Absolutely. I want to first emphasize that the vaccines are really superb. Everything that I'm going to tell about variants, I think just keep in mind, the vaccines have exceeded our expectations. And if you remember last year, again, we did not think that we would be almost all vaccinated at this time. I think we were all thinking that we would start maybe testing a vaccine at that time, and it would take a lot longer and would be potentially less convincing in the results. And the smaller the margin in terms of how well a vaccine performs, the longer you have to test it in order to convince yourself that it's safe and that it is efficacious. So that's one thing. The second thing that I want to say is that the variants that we currently see is something that we have expected. It's nothing that surprises us. And that's something that the virus is basically doing what the virus is supposed to do. A virus has inherently the possibility to adapt to certain circumstances, because it makes mistakes, random mistakes, and these mistakes lead to mutations. And if the mutation eventually affords a benefit to the virus to survive, this variant will grow out and will become the more dominant variant that we have to deal with. So, and we had over the year many variants. So that these are all these different sequences that we obtained from the different viruses since the original virus in Wuhan. But now we have variants of concerns. This is called VOCs, or variant of concerns. That's the CDC nomenclature. And that is because these variants have now advantages that we have to worry about. And one advantage is that they can spread faster. One advantage, and if they spread faster, they often produce more viruses in people, and that can lead to more disease. And the other thing is probably the bigger concern, is that they can evade the immune response that we have against these viruses, the natural response based on a natural infection, or the vaccine response. And so this is what we are watching with these variants of concerns. And you all have heard about the British variant, the South African variant, or the Brazilian variant, but there's many other variants. There's the California variant. I'm happy to talk a little bit more about this. There's the Nigerian variant. There's the Indian variant. So there's variants popping up all over the world. But I want to I want you not to be confused. I want you to just remember two numbers. One number is the number 501. I'm sure you have heard about it. That is a mutation that many of these viruses have, the British variant, the South Africa variant, the Brazilian variant. It is a mutation in the spike protein, which is the envelope of the virus that facilitates the entry, and is really the key for the entry in our own body. And this 501 mutation helps to get better into our body. It has enhanced transmissibility, so it can spread faster, and that is sort of the classical British variant phenotype that we currently see, that has taken over the UK, Europe, and I would say the east of the United States, and many other countries. The second number that I want you to remember is the number 484. That is a second mutation, again in the spike protein, that is in the Brazilian and in the South Africa variant. And this 484 mutation is the one that everybody is watching with concern, because that is decreasing the effectiveness of the vaccine. So these viruses can basically circumvent the immune response that we have. And this became first obvious in Brazil, when there was an outbreak in Manaus, in the Amazon, in people that had already been infected. So Manaus has gone through last year a terrible outbreak, with almost 70% of the population was estimated to have been infected. So there was a kind of herd immunity, and everybody thought that this is it. Manaus has had its share, and they have herd immunity, and that's good. However, then there came a second, even higher peak in Manaus, and that was driven by this variant, which escaped basically the initial immunity, and it happened in people that had already had the infection before. So that is what started to raise concerns worldwide around the globe. So this January, everybody was concerned with variants and the question whether the vaccines would hold against these variants. But I want to also let you know that there have been studies now done in South Africa and in Brazil with vaccines, not with the Pfizer and the Moderna vaccine, at least not that I have seen the results of these studies yet, because they were tested before these variants were there, and there was no special emphasis on these countries. However, for the Johnson & Johnson and the Novavax vaccine, they were tested in South Africa and Brazil, and they had more than 50% effectiveness in suppressing the infection, or the infection with symptoms. However, we know that 100% that all vaccines and 100% of cases are suppressing severe disease against any variant, hospitalization or death. And I think that was the best news for me in the beginning of this year. When I heard these results, I was hopeful, and I remain hopeful, that we will get ahead of these variants. It's despite the 484 mutation. But I see that there's another poll, or no, that's the poll result.
I just forgot to share the last one. So
Okay.
I think I have the power to do that. So with my apologies for being tardy, now I will stop sharing the results, because everybody's seen it and they're good at math.
I can just say one word about the California variant, because I think it's so important to us. So I'm just coming out of a really interesting collaboration together with my colleagues, Charles Chu and Raul Andino at UCSF, where we really teamed up to very fast try to get a handle on these variants. And we have two variants spreading here in California. They are now more than 50% of all cases that we have here. And the interesting part is that we have relatively little of the British variant that is taking over the rest of the country. So somehow these California variants protect us a little bit from the influence of the other variants. We have more of the British variant in the south than we have in Northern California, but here we are still very predominantly seeing these two variants that are spreading in California. These have neither of the two numbers, the 501 or the 484. That's why it was so important to do our own investigation and to find out, are they of concern or are they not of concern? So the CDC has classified them as VOCs of concern. We have shown that they have slightly enhanced transmissibility, less than the 501 mutation viruses that we see the variant, but still significantly more. It's probably a 20% enhanced transmissibility, which also confers well with numbers that we see in household transmissions. And they also have a slight effect on diminishing neutralization, both of the vaccine and the reconvalescent sera that we're testing. It's about a twofold effect on the vaccine, which we think is not going to be significant in any way to weaken the response of the vaccine. So we think that the vaccines, at least the RNA vaccines, will hold against the California variant. One interesting side note is that this is a variant that is very close to the mink variant that you might recall has been happening in Denmark when all the minks became infected and unfortunately were then also killed. But another interesting thing is that we're very, very closely watching is that the Indian variant, I'm sure you have all heard about the catastrophic situation that is currently occurring in India. This is a dual mutation that has the 484, the same like the South Africa and the Brazilian one, and it has the same mutation that we have here in the California one. So it's a combination of the California and the South African one, and we're very much watching this one and studying it to see what this combination is holding in terms of neutralization and transmission.
Can I pose a couple questions before we move into the third conversation branch, just because there's a keen interest in variants here. So one question posed by an anonymous attendee is, understanding it may not be necessary, but for peace of mind, how soon after getting the J&J vaccine would it be safe to get one of the mRNA vaccines, Moderna and Pfizer, I presume, now that vaccines are readily available to everyone? The person writes, my concern is with the J&J efficacy, not safety or production.
Yes, I think I must say that the J&J efficacy is actually very high for a single shot vaccine. And I suspect that it is in the range of the mRNA after the first shot only. There is currently a very large study ongoing with J&J where they're testing a 2-injection regime, which I predict will be as efficient as the RNA vaccines, because just simply how the vaccine is built is very similar to what the RNA vaccines have, and we have seen that is just from the buildup a very immunogenic or very good vaccine target. So I would not abandon the J&J vaccine, especially if you're not falling into the risk group for the blood clotting disease that has been associated with it in very, very rare cases. Yeah. There's really no information currently about mixing and matching vaccines. I don't see any reason why we cannot go with an mRNA vaccine after you have been vaccinated with a J&J vaccine. They are fundamentally different vectors. I'm sure that you are potentially aware of that. The J&J comes piggybacked on another viral vector, an adenovirus. The risk of coming multiple times with the same adenovirus is higher in terms of weakening the immune response against the vaccine than coming back with an RNA vaccine after an adenovirus. So I think also there's no scientific data currently that has systematically tested how good and when should be these vaccines be mixed. I think in Europe it is now, because of the withdrawal of the AstraZeneca vaccine in some countries. I think much more common to use for a second boost or a second shot, the mRNA vaccines. And I think we will get more data out of this to really find out what is the best regimen here in order to be the most efficient.
Yeah. Another question from David is, are we concerned about variants that we haven't yet identified?
Yes.
The unknown unknowns.
Absolutely, we are, and that's the big unknown. Is the question? What else is circulating, and what will circulate? I want to say that the variants of concern only arose when we had some sort of immune response in the population, and that's when they had basically an advantage that they had to adapt and outgrow. We had previous immunity from people who had COVID that was starting to go down. That's usually sort of when variants have their best time, because they are not fully neutralized and they have chances to replicate and evolve and grow. And the other thing is that that the vaccine was coming up with first doses and incomplete immunity. And I think that, again, is the breeding ground for mutations and for variants. It's a big discussion in the field currently. However, what is in the pipeline for us is hard to predict, but we're doing a study together with artificial intelligence experts to actually predict from what we know today, to predict what we still have to expect, especially since these mutations now build on the backbone of the other variants. It's not that they all start from scratch from the original virus, they build on the other ones. And so we're doing a lot of modeling, and I know a lot of people are doing other types of experiments, in vitro experiments, where they try to put a lot of pressure onto the virus in the cell culture and see how it would evolve to get around it. So there is a lot of focus on this, and yes, we want to know what else is in store for us.
Well, the question from Doug is, I think, related. It's sort of, if we don't achieve herd immunity, how likely is it that a new variant will eventually find its way entirely past current vaccines or native resistance from having had it?
It is not excluded. I think absolutely. I think we have to think, is that the best the virus can do what it is currently doing? Probably not. I think, as I said, there is other mutations, and we know if we have a response to a vaccine, or we have a response to the infection, the natural infection, we have in general a broader immune response, against multiple immunogenic epitopes in the virus. When we go now with very, very determined antibodies that are pure, that is just one piece that is being recognized, we can already map the areas on the spike protein that can mutate to inactivate basically these antibodies. And so we can, as I said, predict which areas are sort of dangerous for us and should not mutate. But I have to say that I think we will counterbalance this with repeated booster shots. So there's two things that I think we have to do. One is that we have to adapt the injection, the spike protein. With the RNA virus is the easiest thing to do, because all you have to do again is to change the sequence slightly in the RNA that is being used to inject. So very, very straightforward. And you saw that the Moderna and Pfizer did this in 6 weeks, basically, and gave it to NIH to test. And the other thing is that we have to bring overall our numbers down. So that is the big question. Variants only arise when there's replication. So we still have a high number of cases per day, too high. And I think this has to come down overall, not in the Bay Area. We have very little cases in the Bay Area, and I think that's fantastic. And I'm watching it every day, first thing in the morning, to see if I see any spikes arising here. But I think the key is that we have to bring the overall replication of the virus down in order to avoid new variants to be able to replicate. Now, will that be enough if we have 50% or 60% people who are vaccinated, especially younger people who are not vaccinated, children which are currently not vaccinated? I think it's going to be critical to get as many people vaccinated as possible. Otherwise, we will see all these pockets flaring up like we see currently in Michigan and in Pennsylvania and Puerto Rico, I think we will always have to deal with these pockets, and there's already thoughts in place how we will deal with them in order to directly target them instead of changing mass vaccination for everybody over time. One last thing here is we're talking about the US, we're talking about our herd immunity, we're worried about pockets of variants. The key is really that we're going to have worldwide vaccination, because otherwise we will have pockets of variants everywhere in the world. And I can tell you, if it's somewhere, it's everywhere. They will come back to us. We will not be able to shield ourselves from variants that are rising anywhere in the world. And as I said, we are totally in the same boat. California has its own variant. So I think the key is for us to be thinking about us and to get Americans vaccinated, but the end goal is really to be participating in a systematic vaccination effort that is worldwide.
Amen. I mean, as the great soul singer Solomon Burke once said, none of us are free if one of us is in chains. We're only as safe as the least among us. And that's very much on point. There are a couple more questions about variants and vaccines, but with the permission of my wonderful audience, if I promise to come back to them, I want to get into something that's more perspective, because we're going to leave plenty of time for Q&A. And so Dave Whitmer, one of my board members, I think, asks a question that gets us into what's on the horizon, which is there's still a lot of work to deal with COVID-19 and the virus now. How do we prepare our collective governmental, scientific, and medical systems against future pandemics? And what do you and Gladstone see when you look out at the 2 and 5 and 10-year horizon?
Oh, I think this is what is actually on all of our mind. I think that consumes currently most of my time, is the question of pandemic preparedness. And I'm really happy that we have this discussion now, because it has always taken a second row priority in the last few years, because we have to remember that we had SARS, we had MERS, and now we have SARS-CoV-2. These are 3 dangerous coronaviruses that we had in the last 20 years. And in the meantime, we also have 2 Ebola outbreaks in the Congo that nobody pays attention to, basically, which is extremely worrisome, because these are actually infections that are coming not from the animal kingdom, but that are actually persistent in survivors from the last outbreak 5 years ago. So there's a whole interesting perspective for pandemic preparedness here. But if we're just focusing on the coronaviruses, which are likely to come back in the future, unfortunately, I think we have to really sit back and analyze very, very objectively what worked and what did not work. And I would say there's a lot of things that did not work at the beginning. I think our testing system was really not prepared. I think we were lacking in getting up to speed with it. And I think we are still not where I would like us to see, where we're testing frequently and constantly. And I think, the diagnostic that I described to you, and that other diagnostics, wonderful innovations that are currently coming out of this pandemic, I think is something that we have to really take seriously and see how we will adapt it for the future, and keep it on everybody's radar, and keep people also used to, to testing. I think I will be in a plane in the future, and will look around and think if people are vaccinated or tested, and I would feel better if everybody takes a test before they go onto the plane. And I'm sure that's the same for you. I think one of the things that we're doing at Gladstone is really looking again also very deeply into therapeutics. I think vaccination is important, but it's not perfect, as we know, so we will still have to treat people. And I think in therapeutics, we're currently lacking. We have remdesivir, we have steroids, but all these are for late stage infections. I think we would like to have something that you can give early, so that the virus is cut short and cannot actually come into the lungs or in other organs to really cause any havoc. So we are working very systematically on host-directed therapies. We're looking at the host response instead of the direct virus, and that has several advantages. One is that if we targeting us instead of the virus, we do not have the same problem with variants and resistance that we usually have. as the virus is circumventing the immune response, it can also very fast circumvent the drug that you put in its way. So if we're talking about antivirals, and we have wonderful antivirals against HIV or hepatitis C, we always talk of cocktails. We have to have 2 or 3 drugs that we have to combine in order to prevent this resistance development. So we are really working with many different approaches. With my colleague Nevin Krogan and also Andreas Pushnik from the BioHub, we have done lots of pan-coronaviral screens where we're really looking for host factors that are not only affecting SARS-CoV-2, but also has an effect against other coronaviruses, the common cold coronaviruses, SARS and MERS. And we think if we have a therapeutic like this and another coronavirus comes around the corner, we will be much better prepared to be either using it as a prevention or as a therapeutic tool. So that, and then of course the whole vaccination effort, boosters, adaptations, surveillance is going to be something that we have to take very serious, and we have to stay connected worldwide. I think one of our, I would say, missteps at the beginning is to cut the ties with China and cut also some very important studies that were going on where we were actually looking systematically for viruses in bats in China. That was unfortunately stopped, but this type of research is the type of research that will predict if there's another virus that is evolving that is very close to infecting humans instead of staying in the bats. So I think there's lots of things that we have to learn. We cannot address everything, but if everybody focuses on what they are good at, I think we will have a collective preparedness for the next time that is hopefully better than what we have now. So I want to have one last pitch for something. I think the pandemic has really taught us in science a lot. I think it has taught us that only together we can be fast and effective. And I have never seen a response like this, an outpour of collaboration, cooperation, openness, and sharing that we have had in the last year. I think scientists are usually collaborative, but we also are competitive. You know, we're not one to necessarily, we want to have the upper hand and we want to be the fastest. I think this all has not mattered in the last year. I think everybody has rolled up their sleeves. Everybody has picked up their phones. I have never had so fast responses or so many people reach out in order to tell me what they need, to ask what they can give. And the collective data sharing has also changed. You know, we take 9 months until we publish a paper because it's reviewed behind closed doors by competitors, and they make us go through hoops until they're satisfied to let us publish. Now we publish open access. Everybody publishes everything that they have right away so that it's openly accessible to everybody in the world. And I think this is a very, very important step forward for us in terms of supporting collaboration and transparency and open access publishing. And I think that is something that I really hope we carry forward, because that is what, for me, one of the biggest motors that helped us drive innovation and success in this pandemic.
I'm so glad you brought that forward, because I was struck by that in your early remarks. You weren't only talking about your team and your lab, you used the word colleagues many times. And I was going to ask, so what's it like to collaborate across different institutions? If I may, I want to jump us into Q&A, because there's a bunch of folks who'd love to get your wisdom on things. Can I do that now? Okay. Kathy wonders whether folks are working on individuals with autoimmune conditions which render the vaccine ineffective.
Yes. So the problem is that if you have a condition that doesn't allow you to mount a sufficient immune response, vaccination is not the way to go. I think there's other ways to go, and that, by the way, is why we need herd immunity, and that's why we have to pitch in for people who are prevented from taking the vaccine or who are not, responding to the vaccine. So I think this is really where the collective spirit has to come in, and where it said, okay, I'm young, I might not be at risk, it might be easier to have COVID than the vaccine. I think it's imperative to get the vaccine nevertheless, because you will be helping somebody else who will not be affected because of you. So I think that is an important issue here. But having this condition is not making you completely helpless. I think what we can do, and what is done very, very efficiently from the beginning, is we can isolate the antibodies that are generated by the vaccine, usually actively, because you give the immunogen and your body basically builds it up. Instead of doing this, you can give the antibodies passively. You can purify them and you can inject them so that you have transient protection, the same protection that somebody else would have who had the vaccine. The problem is that this is much shorter lived. So this can be given for, in situation when you have contact with others, or you are in an at-risk situation, or we have high levels of virus around. I can give you one example. I have worked with my colleagues, Peter Walter and Ashish Manklik at UCSF very early in the pandemic. They are not virologists at all. They are not immunologists either. They are very, very excellent hardcore cell biologists. But they had a tool where you could generate a very special form of antibodies very rapidly. And they had this tool because they use it for their lab research. They make antibodies to detect certain components of the cell for their research. They have never thought about using it as a vaccine or an immune therapy strategy. But they knew that these were very, very good and very stable antibodies because they come from the camels. And they're slightly different than the human ones. They're smaller, they're more compact, they're more durable, and they thought that they could lyophilize them or make them into an inhalant. So they generated these antibodies in that form and then put it into an inhalant and showed that if you would basically give a puff in the morning, you would protect your respiratory system so that no virus could come in. You would have to repeat this. But this was the vision of Peter when he talked to me. He said, this is what I want. I want to have this in little inhaler. I want to take a puff in the morning. I want to be protected. And that is sort of the type of technology that will help people who will not have an active immune response, but could be passively protected in that way. And there's a lot of innovation going on in that area.
That's encouraging. I'm gonna bring together two questions in the interest of time, one from Barbara, one from an anonymous attendee. Part A is, can you speak to vaccine safety in pregnancy? And part B is, should we expect a booster for Pfizer and Moderna later this year? And can boosters be variant specific?
Yes. I can talk to the pregnancy issue. I think in general, it is recommended for pregnant women to take the vaccine. I think there is also the first study just yesterday came out showing that there's very low risk for pregnant women to take the vaccine. There's great advantages because pregnant women are not getting very often infected. However, when they get infected, it can be deleterious. So I think the recommendation is to take the vaccine in order to mitigate that risk. The other study that came out not so long ago was showing that breastfeeding after vaccination is actually protecting the baby from the infection. That's something that we see with many viruses, and it has now also been formally shown for SARS-CoV-2. So I would very much encourage young mothers to get who are breastfeeding to get the vaccine because it will also benefit the baby. The second question was whether the vaccines are going to be modified to include the variants, and the answer is yes. I think both Moderna and Pfizer are working on this. I said in very short time they generated vaccines that are targeting specifically the 484 mutation that I showed you before, that I talked to you about before. And I think the question when these boosters are going to become necessary is still very open because we don't know the durability of these immune responses. I think we're also looking very closely into, is it just the antibodies or is it also other components of the immune system that get meaningfully engaged after immunization and protect us? So that antibodies is one part, but for example, T cells are also very important in that. So this is all being analyzed currently, and I think the projection is currently that there's a 6 months protection for sure, and we all expect this to be prolonged as the studies are going on. It's just a matter of time because we haven't really watched people longer than 6 months now with all these studies. So I think this is a big question, but I think it is expected. I think, of course, the CEO of Pfizer and Moderna saying we should have annual booster shots, but that doesn't mean that we have to have them. But I think there might also be another thing to keep in mind is that there are differences in age, unfortunately, on how we react to these vaccines. First of all, I have to say that these vaccines, the RNA vaccines, have surprised us in the way that they're inducing a very robust immune response also in the elderly. Unfortunately, if we grow older, our immune system becomes more and more reduced in the way it can respond, and so that is a limitation, and that is a problem, for example, that you see with flu shots, where we have to have stronger doses for people above a certain age. So I think what we will probably watch is that there might be booster shot recommendations based on age in frequency, potentially. We know that the 12 to 15-year-old kids had really a fantastic protection because they just have a very young immune system. They will just boost out and churn out these antibodies like no tomorrow, and have little problem, you know. But unfortunately, when you grow older, that is less durable and less strong in the response. And I think that's when we have to be more careful. And for sure, we will have these booster shots that are variant specific. They're very easy to produce. I think the FDA has indicated that they don't have to go through the whole cycle of, you know, testing that the others had, because the principle has worked. And I think the goal in the future is to have these multiplexed, vaccines where we're not just only using one spike protein, but injecting a cocktail of spike proteins that might have a broad range, that might actually go even beyond the variants of SARS-CoV-2 and protect us in the future from other coronaviruses.
Wouldn't that be wonderful? Well, our good friend Brad poses a question that I think is a lovely way to sort of step back and have perspective in what has also been a challenging year for our country in other ways. So I'm going to read you his question. He says, you know, firstly, thank you for all the incredible work and for emphasizing the essential nature of vaccination, but the caution that we are not at mission accomplished yet. On a different subject, as a biology major in 1976, Brad is a medical doctor. I was fortunate to learn about Rosalind Franklin and her role in the discovery of the double helix. What has been your experience as a woman in medicine and science, and how much progress has been made with diversity?
Well, thank you very much for that question. It's very interesting. I was just interviewed by ABC News yesterday about exactly that topic, and because they noticed that actually in the pandemic, a lot of the local faces in science were women that were responding to the pandemic. And these are my very close colleagues in Stanford, Catherine Blish, and Sarah Stanley at UC Berkeley, and many others. And many of our male colleagues, we have been really working closely together. We have actually a standing Bay Area virology meeting where we discuss Wednesdays at 7 after the WHO meeting at 5. So sometimes very early.
You mean AM, right?
Yes, I mean AM. But it's just such a great community that needs to be supported. So I would say I think it is very heartening for us to see that so many women are stepping up and being successful in that pandemic. But in general, I think we have come a long way. I mean, I lead now the Gladstone Institute of Virology. We have 2 directors at Gladstone that are women. We have many senior and mid-level women scientists and faculty, which is wonderful to see. And when I started 20 years ago at Gladstone, there was no woman faculty and no woman director at that institution. So I would say we have come a long way. But the fight is not over. We all know that there's still bias in women and in men. And I think we will continue, hopefully, to be a good role model and to inspire our daughters and granddaughters to be ambitious.
Well, inspiration is a wonderful word. to bring up here at the close in our twilight moments, because it's been amazing to have you with us tonight. You're so close to so much deeply important work, and I'm really just feeling grateful for you and your whole team and your fellow scientists who, you know, times ago in our popular culture, a scientist might turn up on the Johnny Carson show, right? They had more standing in our public life than they have of late, and that's a shame. And I think it's just, we all owe you and your colleagues a debt of gratitude. Although I felt like I had been kicked by a horse when I got my second Moderna vaccine 10 days ago, I am feeling so much better for having had it. And we really appreciate your work, so much so that the foundation will be sending a grant to your lab in honor of your time tonight. And folks on the phone, if you're curious, if you Google the word Gladstone Institute, you'll find a way to be charitable if you wish to be. We appreciate it so much. Thank you. And thanks all for joining us. We're coming back to you on the 20th of May with an amazing leader in California and nationally around immigration, Angelica Salas, who runs a nonprofit called Churla, which does a bunch of amazing advocacy and direct service work for California's immigrants. So I hope you'll join us then. Stand by for more about that. Thank you, Dr. Ott. Thank you, Melanie. Have a good evening and stay safe out there.
Yes, thank you, Terrence. Thank you for the invitation. Thank you for the great questions. And again, thank you for the important work that you're all doing.
It's our pleasure. Thank you.